Hi, if you're watching this video, you're watching my video on fluid systems. This will probably be the final lesson in mix and flow of matter. So this lesson will focus on the application of some of the topics we've talked about and how the science that we've learned in this unit is applied in everyday life. So fluid systems, using what we know of pressure and compression, we apply it in everyday machines. So in class, we'll be talking about, well, how do you think we use pressure in everyday machines or everyday tools? And some people may give different answers. And if you're watching this at home, I want you to think about what type of machines or what type of tools do we use that involve high pressure or fluid systems, or think fluids under pressure, for example. A good example would be hydraulics. Hydraulics uses liquids under high pressure to move things. So a good example here would be this machinery. This machinery here, you can see these connections here, 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 and well here. Oil or lubrication or different types of liquids are under high pressure. And to get this arm to move, different amounts of pressure are applied in different parts. And that causes the arm to bend or straighten. Now remember, liquids are incompressible, meaning that as pressure is applied to these tubes of oil or other whatever liquids inside, it pushes out with just as much force in all directions. So you can push a lot of force in many different directions because of the property that liquids are incompressible. They push out just as hard. Now, the question might be asking, well, why don't we just use the same pressure to move the arm? Well, the upside of pressure in liquids is that liquids also lubricate and move smoothly. If the whole thing was solid, it would rub against each other, it could damage different parts, it could wear it down, while hydraulics can last longer because liquids don't create that friction you feel or see with solid objects. So this video will talk about the power of hydraulics. You can check them out on D2L if you want to click on that link. Pressure systems, we also use hydraulics to move liquids large distances. So understanding that pressure likes to move from high to low, so pressure likes to move from high to low pressure, then you can use that understanding to move water large distances. Now, aqueducts is one of the great Roman, I believe Roman inventions, where they used these types of structures to transport fresh water across large distances. And that's because as you move down the aqueduct, the pressure is lower. The pressure is lower here and higher up here. So liquid's going to move from high pressure to low pressure. And that's how you transport large amounts of fresh water to cities like Rome that had millions of people back before electricity was harnessed. So one of the great inventions of the Romans were the aqueducts. So this is how it's used. So you can see that the reservoir here, they would have basically a tunnel, an aqueduct bridge, and through here you have this immense amount of pressure. All this water is collected here or is held here, and it's pushing against each other because there's a lot of water here. On the other side, not as much water, so the pressure is lower. In addition, you can see the aqueduct is moving downhill. So now you have high gravity here and lower gravity here. So again, this high gravity, high amount of fluid makes the pressure very, very high, and so it pushes the water through the conduit, down the bridge, and into the city. Modern aqueducts don't necessarily need these large structures. They can use underground mechanics or different pressure systems to move water to the city that they need. But it's entirely based on a system that was invented or developed and mastered thousands of years ago. So it really gives credit to the Romans' ingenuity and scientific understanding. In Alberta, we use pressure systems to transport oil. So pipelines will have a very high pressure here and a very low pressure down here. So again, the oil will want to move from high to low down these pipes. Now, you have to carefully regulate the pressure because if the pressure gets too high, remember, liquids push out with equal force. And if the pressure is too high, it could push out this way, too hard, in all directions, causing oil to spill out. And that's what a main cause of oil spills are along pipelines, is the mismanagement of pressure along these pipelines. What you also may notice, except for here and here, that the pipeline wants to be roundish. It wants to curve like this, right? If you have very sharp corners, pressure can build up in those corners, and as pressure builds up, you can cause a rupture and oil can leak out. So this is applied in ancient times, pressure is applied now to get us fresh water in cities, and Alberta's biggest industry, oil, uses pressure to transport oil across large distances. So most pipes transport liquids to avoid too many bends. We already talked about this. We talked about the fact that the pipelines don't want too many big bends, because every time you bend, you start increasing the pressure on that bend. And if the pressure gets too high, you can cause a spill. Pneumatic systems, pneumatic, not hydraulic, pneumatic, instead of using liquid pressure, they use air pressure. They use air pressure to move or control machines. So these systems are similar to hydraulic systems, but they use air pressure instead of liquid pressure. An example of this would be two syringes attached through a tube. As you apply 10 newtons of force on the gas gets pushed through this tube and pushes back with 10 newtons of force against the other syringe. So we can talk about its uses in this video. You can check that out on D2L. Hydraulics and pneumatics, the difference between them, like why would you use hydraulics versus pneumatics? Well, hydraulics produce an immense amount of force because of their property of not being compressible. Liquid's property of not being compressible allows you to create an immense amount of force, rather than, while pneumatic systems, the gas can be compressed a little bit, so you lose a little bit of force. However, pneumatic systems are smoother and faster than hydraulics. So if you want machines that do quick tasks but don't require a lot of force, pneumatics are the machines you want to use, right? So small machines that build parts, or factories that use small machines that don't lift heavy things, will use pneumatics because they don't need the power, they need the speed and accuracy and quick movements. In addition, pneumatics don't produce any waste. They use air or compressed gases, while liquids in hydraulics can use oil. And as that oil is used up over time, it does need to get replaced. It's not infinite, right? So it needs to be replaced as you use that oil in the hydraulic system. Pneumatics don't need that, right? They just keep using air, and they keep cycling that air for their quick machines. That basically covers how pressure, compression, fluids, gases, all that stuff is applied in everyday life. Mostly focuses on pressure that we talked about earlier, but you also need to understand the states of matter. You need to understand how particles move as a gas, how particles move as a liquid, the idea of pressure on liquids and gases. So it mixes and matches different concepts that we've talked about in this unit and sort of shows you how they can be applied in everyday life, right? Science is not just in the classroom. So this is a relatively short video, probably the last one for mix and flow of matter, and maybe the test will be coming up soon after you watch this video. So please review the other videos and check your notes. See you next unit.